who is Philippe Limantour, Chief Technology and Cybersecurity Officer at Microsoft France. Philippe's main mission is to lead Microsoft's strategy in France in terms of innovative technologies and cybersecurity, including artificial intelligence. He draws on over 30 years experience in the design and development of innovative platforms in the financial, media, and telecom space and defense sectors. He's also a serial entrepreneur in the startup field. Philippe holds an engineering degree, 2 master's degrees in science and executive coaching, and a PhD in mathematics and AI. Philippe started working on AI 37 years ago to finally live the days he dreamed of. The title of his talk is Responsible Generative AI and Microsoft Cloud. Philippe, the floor is yours.
Thank you, Alan. Thank you for the organizers to inviting me today. I'm delighted to share some insights with you all on latest thoughts about how to scale AI responsibly and deploy AI at scale. By the time we get the So I've been dreaming that those days, you know, I've started almost 40 years ago programming artificial intelligence, and now I'm living in the world I was dreaming in when I started. I'm still doing some research on AI. So as I mentioned, generative AI and especially ChatGPT has been adopted by a huge number of consumers in the fastest pace that we've ever seen. Maybe the reason why the first key differentiator from, you know, before and now in AI is that we never had machines with such understanding. We've been, as human beings, you know, we had to learn how to use a keyboard, a mouse, buttons, menus in user interfaces for decades to try to talk to machines and get the poor feedback from them. Now we can have a dialogue with the machines, and that's the reason why so many consumers embraced those new AI models and use cases. You can talk in any language, in any business domain, ask anything, almost anything, and you would get a feedback from the machine in the same language, in the same kind of writing or speaking as you are doing. It's kind of talking to a mirror, which raises some questions, because when doing that, the machine is enforcing you to trust it. It's like having, you know, an answer which resonates in your mind because it's written in the same kind of words and same kind of grammatical way that you would. This is an example of the way we use. Have sound. I don't know if you. So that's really the first key differentiator, and as you've seen, compare it to learning the way to use a tool like Excel. You know, it would take months to get the same results. that you are going to get in few minutes, just asking, talking to the solution. So in the next month and yeah, months, I think, new software will arise, and you'll see disappearing the user interfaces as we know them. Maybe there will still be some buttons, because in some kinds of a quick click could be more easy to do than talking to the machine. But that's a key revolution which is coming. It allows also people to get access to complex tools in an easier way. So it's kind of a great news for inclusiveness. You don't master a language, you don't master a tool, but then you can just talk to the tool and get access to it and do something you never were able to do, or you would be able to do if you would take months to learn. So that's changing the way people will be educated, and the mobility within companies and across companies. If you have the skills, if you know how to have a dialogue with a machine, then you can access almost whichever tool you would need to perform your job. The second thing is that we never had such an intelligent model. It's not general intelligence, but it has sparks of intelligence, especially GPT-4. If you look at all the generative models so far, they're all very good, but GPT-4 stands outside of the crowd. It's amazing the capabilities that model has, and that's only the beginning, and there will be others from OpenAI or others. But it's really able to generalize, so that's the first key thing we would expect from an intelligent something. So we can learn from examples. That's a few shot learning. It can reason, and we show an example of reasoning. The thing those models still lack is planning, but I will show at the end of the keynote ways we have now and current research on adding planning capabilities to those models. So this is something brand new. It has only 6-7 months, but already we had to change the way we benchmark those models. We used to benchmark them, we're using a technology benchmark, but now we have to use human beings benchmarks. So that proves that we scaled up. Something new changed. The other thing is that it's breaking the way people in AI used to think for decades. Usually with traditional AI models, you had to train a model for every business domain, every use case, and every language. So you do summarizing in financial services in English, you have to train a model. Do the same summarizing in financial services in Spanish, then you have to train another model. With the new generative AI models, it's what we call foundation models. It's a single model which is able to perform in most of the languages, almost all of the business domains, and with capabilities that embrace a lot of different use cases. It's pre-trained, so that's different also. It has been trained once, and the same model can do many different things. The example I've shown in Excel is using the GPT-4 model, and we'll show you next another example using the same model. But you'll see it's a very different use case, very different way of using it. So you don't need to retrain your models. It takes you on a faster way to go to execution. We have customers who do workshops with people who don't know AI. They just talk about their business use case, daily complex processes they want to optimize. And in a few weeks, they can put that in production because they are explaining their issues in natural language, and the same natural language is the one which is used to steer those models. So it's kind of, just adding things, and I will talk about that. But on top of that, but to have that model being able to execute the use case in the domain and in the language of the user. Today, most of the models are in production are using text, but there are by nature multimodal models. So expect to see in the coming months and years models where you would be able to not only put text, but also images, videos, and other things. And they are able to call APIs. So they are able to, with an orchestrator, to call tools like the Excel one, talk to the model, and the model transforms your request into a call to the Excel API so that it can be executed by the solution. One key mistake has been to think that those models are knowledge bases. They are not. They've been trained to execute use cases, to process data, but they are not meant to be a knowledge base. So if you ask the model about some knowledge, you will end up with hallucinations in most of the time. If you give a context, if you give information and ask to process that information, then you control the use case. Then you control the way you process the data, and you will hardly reduce the what so-called hallucinations, which are basically out of context answers. We call it hallucinations, but they are not the answers you are looking for. Because those models are AI, they are statistics, so they can make mistakes. This is an example of inputting an image. So bottom left side is an image, pink file of a financial services process. Just input that to GPT-4, and then you ask, what's that? That's a process with some things. Can you explain me what happens after credit check? And you understand that the model not only reads the picture, but understand that's a process and understands which steps are after this one, which are the decision keys, what happens, what are the documents which are asked to the consumer so that it can process on the right way or the wrong way of the process. So imagine now tomorrow you give that model a set of processes like that, and then you give context, and then you can have that model help you understand where you are in the process and help you execute that. So it's not only understanding, it's also reasoning capabilities. So it started with, on Microsoft side, with a partnership with OpenAI more than 4 years ago now. So OpenAI is the company who is designing, outputting the large language models, which we call GPT, in GPT 2, 3, 4, 3.5, 4. And Microsoft Cloud partnered to use those models. So we take the model, it's pre-trained, we don't modify it. We take the model as is from OpenAI, but then we add things so that you can execute it in a trustworthy manner. Not only OpenAI models, but generative AI models are made every day. So we have a partnership with Hugging Face. We did a joint partnership with Meta to develop the Meta Llama 2 model. Microsoft Research is working on its own models, like Orca, which is same capabilities as GPT 3.5, but at a fraction of the size of the model. That's a direction we are taking. It's trying to reduce the size of the models. And you can bring your own model. So OpenAI, and especially GPT-4, is by far the best model so far. But we are providing the choice of using open source models, and there will be other models, and maybe tomorrow another model will be better than the GPT-4. But all those models require the same foundation. So the first one we developed a few years ago was a supercomputer. So we invested a lot of CapEx in building a supercomputer with dedicated networking infrastructure. So the first thing is it's a huge CapEx investment to be able to execute at scale those models and silo the full set of data while you are executing a large farm of execution processes. The second step is to add a lot of work on securing, adding data privacy compliance. So we've always been working with that. So it's almost embedded in the Microsoft Cloud Azure environment, but we've been working hard to harden the execution of those models. Data and metadata stay in the open environment. Data is protected, it's never used to retrain any model. It's really siloed from one customer to another one. It's really private environment. On top of that, we've also worked on adding responsible AI frameworks. So it's not only principles, it's really an execution framework. It started 7 years ago already at Microsoft Research, long before we had those generative AI models at the early stage of AI at scale, I would say. It's been used in Microsoft Engineering for the past 6 years already. So every product service using AI we've been producing for the past 6 years already had those responsible AI execution frameworks, mandatory frameworks for our engineering teams in place. But now we've put that at another scale because of the complexity and capabilities of the large models. And I will dig a bit more later on that. We've been also doing a lot of work on hardware and maintained our sustainability goals by 2030. It's a lot of work. Generative AI are large models, are consuming more energy than single models. But since they are pre-trained, since a single model can do what we've been doing with tens, thousands of models, there's kind of balance there. And then we are working on removing water for cooling. So we are putting electronic parts in directly in the electric, so using no water to do cooling. We are working on moving the switch equipments to optical ones. It consumes less and gives lower latency. Then you can have data centers or far apart from another one, and then you can pick up the right length to put the data center. You have more choices to put the data center in a place where you could get rainwater, for example, to use the cooling or have less impact. So lot of investment on the hardware side also to lower the impact of, I would say, all the computations and especially the AI ones. And then we use AI in two ways. We have what we call Azure AI, and Azure AI is the way to expose those models to users so that you can develop your own use cases. And the other way is we are consuming Azure AI services to develop what we call the Copilot, which resonates with responsible AI. Copilot means that in any AI product we are delivering, there's always to be a human being in the loop. So you have to have a human being at the end looking at the output of the model and deciding if I would keep or not or modify the contents which was generated by the model before using it. We don't provide in our own solutions, we don't provide an AI solution where it's fully automated. You always have to have a human being. And the second thing, which is also resonating with responsible AI, which should also be included in AI Act, is that you have to be clear with the user in the user interface that the user is communicating with an AI model. It should be clear that it's not a human being. You are asking an AI model so that model can output things with errors or being out of context. So on the Azure AI, it's all about, so we have a lot of customers developing quickly use of those models. The most used one now is about knowledge search, putting at another level the way you can use data to turn data to information and knowledge, both for consumers and employees. The second one is reinventing the customer experience, because you can get rid of those complex user interfaces and have a more natural language interface. And the third key one is because companies are still in their digitization journey, is using those models to application modernization, securing application code, transforming them to be more digitized. And the other way, so we are consuming those services to develop embed those large generative models capabilities in all our solutions. So target is really to have all those solutions using those generative models as a new way to interact with them and also to add capabilities. So I've an example with Excel, but every single solution will be using those services, and that's the same services that anyone can consume from Azure AI. So what you've seen in Excel video, you can do it. It's using the same services that the one we are exposing in the cloud environment. Responsible AI is really something which is taken at the highest level of the company by Brad Smith, our CEO, and also in charge of compliance and responsible AI. It starts with a framework. So you can look at the model, and then on top of the model, we have what we call a safety system controlling the input and the output of the models. Then you have meta prompts. Meta prompts are ways to add more requirements to the request of the user. So, for example, if the user is asking something about knowledge, you can add a meta prompt saying you should answer only if you find the answer in the documents provided. If you don't find the answer, say politely that you don't know. That's a meta prompt, adding requirements to enforce the model to do what the user wants. And then the user experience, and I tackled that, first thing would be making clear for the user that he or she is using an AI system. Second thing is providing processes, and there are complex processes to be delivered from the very beginning when you think about the AI system. Which are the stakeholders? What do you want this system to do? What do you want this system not to do? What could happen? What if, scenarios? Then we have red teaming. So red teams are people who are not in the AI, not only AI experts, trying to fake the model, trying to put requests that would allow the model to go out of the race, so checking the controls and adding more controls and fine-tuning the meta prompts. So red teaming is very important to try to shake the model and test it. It's kind of a crash test for the model. And then, of course, we are providing a lot of tools. This is a content filtering tool, which is available for any model to be deployed in our environment, where we add controls on the input and the output of the model to check for the content, like is it violent, is it so there you have different levels you can control depending on the use case and depending on the users of the model and their training phase, I would say, or the context of using those models. Lastly, I want to touch on, new research. Every day are amazing papers delivered. So it's hard to follow the field, but I want to point the attention on it's the latest Microsoft research paper from last week called AOT, Algorithm of Thoughts. So I told you that those models don't have embedded planning capabilities, but by finding a new way to add ways to mimic algorithms when you prompt the model, you can get interesting results. So it's basically something we've been taught for years. You have a complex program, a complex problem, you split it in sub problems, you try to find solutions, then you do pruning on the different solutions which were provided. You make decisions, you can backtrack and prune again, and then you make a final assessment. To do complex things with models, usually you maybe have heard about chain of thoughts. So asking the models to do something and then another thing and then another thing. So those complex to sub problem split would be done sequentially. But for complex use cases, you can end up with dozens, hundreds of calls to the models. which adds latency and adds a lot of costs. With the algorithm of thoughts, we've demonstrated that with a single call, we can do better than what we've been doing with a kind of chain of thoughts algorithms with dozens of calls. And then we see also the power and the capability of reasoning of those models, because we ended up also finding that the large language model was even able to perform better than the algorithm which was provided to them. And that's an interesting field also on research. And, there are still black boxes in the way those models are reasoning and working. So it's, I think, a good work to be working on for the next months and years. So to end up, we've seen, in the past decade, an acceleration of technology driving GDP growth, especially in what we call the digitization area and era. So from transistors to the arrival in internet and new capabilities to develop more modern computers. We expect that AI will even inflect that if we take it seriously with a responsible AI way, ensuring that we guide the use cases of those models, put the right controls on top of it. One way we do that is we don't provide access. We don't allow anyone to get access to those large models in our responsible AI framework. You have to fill up a form to get access to the models. So we don't put the models in the hand of everyone. You have to explain what the use case, what is your intended use case, which model you would like to use, why. And then we do a risk assessment. And if we think that the risks are too high, we don't provide access to the model. And then we engage in a conversation when we put the process that I've shown, with analyzing the responsible AI framework against that use case to check if we can help the consumer or the user to add controls, add frameworks, do red teaming, so that we can provide access to the model. With that, thank you very much for listening to me, and thank you. Don't know if you have time for a few questions, if any.
Hello. Thank you very much, Philippe, for this very, very interesting talks. I have a question here from the audience. The first question is regarding the question, why is Gen AI different? What was the decisive step from the traditional model to the foundation model? What triggered the change?
I think the GPT-3, 3.5 models was something we expected as AI experts. It's using an architecture which has been known for years, which was developed by Google, the transformer model. We don't have the exact details on how GPT-4 has been mastered, but that's where the change had happened. The scale is one answer. You find that? Yeah. Okay. Yeah, and the way I think the combining different models with a large scale is one answer. There are new, if you look at liquid networks, for example, that's a very new way to think about artificial intelligence networks, networks which are reorganizing themselves. So MIT just released a paper on that. So there are different fields, and combining in our implementation of the Copilot approach, we combine knowledge graph with large language models. So there are still a lot to do on research on those models, and we are still at the very beginning but already amazing outputs.
Okay. Another question was, can you give more details about the idea of a planetary computer?
Oh yeah, I didn't. So planetary computer is a project we started a few years ago in the aim of providing access to data on the planet, so about the planet. It's a lot of work done by with Microsoft, with foundations, with associations, with a lot of people to gather data, assemble data, expose data about the planet, so that people could check. For example, with using satellite images and AI, we can look from the space at the turbines in a factory and detect how fast the turbine is working. The faster the turbine is working, the more the factory is working, and the more carbon emission it's exposing. And we can, with mathematical models, we can estimate the carbon emission from those satellite images of the turbine moving, and compare that with the exposure that these specific factories is documenting, checking if they are telling the truth or not. So it's really about using our capabilities, power, capability of storing data and AI algorithms to help people work on the benefit of the planet.
Okay. Does anybody want to raise their hand? Yes, please.
I love mine of the One Goal Initiative for Governance. I would like to ask if anybody is looking into a method to develop AI that is not geared towards making sort of a double of the human, like that would not think like a human, that would not think like any other creature either, that would just, use some other approach.
The good question. I think the aim of the AI scientists was not to mimic the human. It's not in the intent in the way the models are architectured, but saying that we do from what we know today. So we have a rough idea on the architecture of a brain. That's why we started trying to mimic the links between the neurons and find mathematical models for that. We do whatever we do because also we have to provide data, and the data are today data which are made by humans. So mimicking the brain architecture and feeding the models with human-made data make them closer to mimicking humans, but I think that's not the intent. But what we are seeing with models like GPT-4 is something else. We don't exactly know all the details, but for example, those models were able to create a meta representation of the languages, which we don't do, and we don't exactly know how to do that. But when you talk to a large language model in English or in French or whichever, the model is not listening in English or in French. It's listening at a higher meta level. So it's the same if you talk in English, in Spanish, in Python code or Pascal code or COBOL. For the meta language, it's all made of vocabulary, syntax, and grammatical rules. So that's an example of something that it's not mimicking a human being. And in the reasoning capabilities also, they are doing things that we don't do as humans. So, but it's still a lot of things to do. And maybe when those models generate new data and use those data to feed new architectures, then we'll come closer to something we don't know. And maybe those will help get the bias of the humans, and maybe they will find, and that's our hope also, using those models to find ways to improve our life on the planet. improve the inclusivity, allow more people to get access to education, allow more people to get a job, allow more people to get the right level of education. And that's the ultimate target, I think, of using those models.
Okay, thank you very much. Let's thank Philippe again.
Thank you.